Figure 2 shows the line with the equation y equals 10 minus x and the curve with the equation y equals 10x minus x squared minus 8. The line and the curve intersect at the points A and B, and O is the origin. Calculate the coordinates of A and the coordinates of B. The shaded area R is bounded by the line and the curve, as shown in figure 2. Calculate the exact area of R. So I've got the question summarized here then. Let's have a little look at it. So for part A, these lines intersect when their y values are the same, of course. So 10 minus x then is equal to this here, 10x minus x squared minus 8. Move everything over to this side, so we get an x squared moved over. When we move the x over, it becomes minus 10x. From 10x to minus 10x. There's already a minus 1 there, so that totals minus 11x. Move the 8 over to become plus 8 equals 0. We've got a 10 there. Plus 8 is 18. So that's good because that's 9 2's. So here we can factorize. And as we said, we think it's 9 2's, so let's put that in. Minus 2 minus 9 equals 0. So that tells us then x must equal 2 and x equals 9 are the two solutions for the x coordinates of A and B. And when at x equals 2 then we can get y at x equals 2. Y is equal to 10 minus 2, which is 8. So the coordinate of A then is 2 and 8, and also at x equals 9 now. Similarly, y is equal to 10 minus 9, isn't it? Which is 1. So the b coordinate then will be 9 and 1. So there's our coordinates of A and B. Calculate r exactly. Well, we can see it's the area, so if we just take slices of this area and take vertical strips. Should be vertical, rather badly drawn, I know. So let's take our vertical strips and I'll try and draw it once more, a bit better. Thickness dx, height the difference in the y's, and we can sum those segments between the x value here and the x value here between 2 and 9. So area then. So r is equal to sum the segments between 2 and 9 of the difference between the y values. The top y value is this, so it's 10x minus x squared minus 8. Take away the bottom value. The line underneath is 10 minus x. Put it in a bracket because there's more than one term. dx. So now it's a simple integration, isn't it? So that's equal to the integral between 2 and 9. We've got 10x minus x when we expand the bracket, so that's 11x. We've got a minus x squared. We've got minus 8 minus 10 is minus 18. So that's equal to 11. Raise the power by 1 and divide by that number. Minus. Raise the power by 1 again to 3. Divide by that number. And the 18 integrates to constant times x, isn't it? 18x. And that needs to be evaluated between 2 and 9. So let's see what we've got then. That's equal to top value, take bottom value, put the 9 in. 9 squared is 81. 81 times 11 over 2 minus 9 cubed over 3 minus 18 times 9. Okay, and then it's take away, put the 2 in here, so it's 11 times 2 squared over 2 minus 2 cubed, which is 8, so I'm going to write that down straight away, over 3. 2 in here, minus 36, isn't it? 18 2's are 36. So let's tap this into the calculator then. Let's swing it over here first of all, so that we can write the left-hand side. So we've got bracket 11 times 81 divided by 2 minus 9 cubed over 3, just 9 power 3, jump out of the power, divide by 3, minus 18 times 9, close that bracket, take away the other bracket, open bracket here. I'm going to move the calculator over so I can read it easily. Put the calculator here then. 11 times 2 squared. 2 squared is 4. 4 over 2 is 2. So that's 22. So I'm going to put 22 minus 8 thirds minus 36. Close that bracket. Equals, we get 57.166 and so on. Or 343 over 6. And that's units squared because it's a measure of area, and that's the exact answer. And I think it did in the question say, calculate R exactly, 343 over 6. Which we could actually work out. It's 57. So it's equal to 57 and probably 1/6, isn't it? Because 7 6s are 42. 57, 57 times 6 is 342 and 1 more is 1/6. 57 and 1/6 if we want to write it like so. Units squared.